Welcome to a new test and teardown video. This time it's an RC meter. I think this one is a radiometer. And I hope I can prove it, but I really don't know because there isn't anything written on the outside that reveals its true origin. But if you look at my previous video called Radiometer MM1, I show an older version, the 1C version. I'll just put in a picture of that so you can probably see the top screws, the top mechanics, the way that this one goes in here and the way that all that is made. Also try and compare, the chicken head knobs, the banana plugs, the whole thing with these around here, and I think it is a radiometer, and I think this one is from about 1940 to 1945 or something like that, because I got MM1C from about 1947, so it is really that old. I don't think this one can do inductors. This is only resistors and capacitors, and we got some capacitor ranges here, and we got, what is that, control? I don't know what that is. And we got capacitors here, right? And this is as old as when small capacitors they were measured in millimeters or centimeters, and that is some really weird way to measure small capacitors. And then we go to microfarads, and there's also a little percent, and then it goes to that one, and it's probably a ratio between this and that. This one is not working. This one is probably a resistor. Yeah, this is a wire wound resistor, and this is probably some gain setting for the magiceye. I really love instruments with a magiceye, so that is definitely why I got this one from the local flea market. Yeah, I can show you. Let me show you the back here, right? See, it is that old, and they say here 220 AC written in text in Danish. And then this is earth chassis for protection, of course. And I mean, everything here just tells me it's a radiometer. The whole mechanics and all that kind of stuff is the same, right? The weight of this unit is 5.2 kilos, and it is 17.5 centimeters deep. The height is 18 centimeters. And the width is 25.5 centimeters. I think we need to open it before I just plug it in. It's just a stupid idea to plug in stuff like this. So yeah, let's open and let's see. The first thing I figured out was this plastic here around this just fell off. And then I wanted to take out the magiceye to see what kind of magiceye it is. This is an EM4, and normally this is rubber, but it turned into stone or something like that, so it cracked when I tried to remove it. But now I could easily pull out the tube from the socket and through the hole. Look at that, quite nice. So now we'll of course put back the magiceye. And what else have we got here? That's an EF12 pentode, and this one is a 6.3 volt filament. I believe the EM4 is also a 6.3 volt filament, and here is an AB2 double rectifier diode, and that one is running at 4 volt filament. So that means the transformer needs to have two secondary windings or low voltage windings. And this one is of course rectifying the high voltage. And that is all there is of active components. So I think I figured out why this is not working. And this is just because this chicken head knob is kind of cracked. So that is easy to repair. I do believe I got exactly this model on stock. So that is something I can easily do. The bananas is quite good shape. The switch here is working all right. There's a tiny little transformer. And that is of course the end of the rectifier tube. Got some capacitors here. And this of course chassis. Oh, look at that. That fuse is just super nasty. I really don't know why. It's always the fuses that looks like this. So they made these sockets of some sort of special metal that just turns into stuff like that. We got some, I think that will be capacitors, right? We got some hand writing. Let's see if I can get this into focus. So I was able to get some really good pictures of this. It says udskift. I mean, this is changed. 1650. Nielsen. So that's probably the name and even a nice signature. So those two capacitors, they have been changed in 1950. And we know when all the different tubes, they were released, right? So what I think this unit can be, it cannot be earlier than 1939 because of that is the newest of the three tubes, and it cannot be, newer than, older than 1939 and not newer than 1950. It must be that way around, right? Because this is when those two capacitors, they were changed. And they look a lot like they definitely need changed again. See, this one is completely broken apart. So I think I need to desolder these and figure out what is going on. But I think this goes to the bridge system. So that's probably just some reference capacitors when you're in capacitor mode. So maybe just in resistor mode, I don't need these, I guess, so I could probably just leave them. As long as the high voltage stuff here is okay. I mean, I don't know. You can't really smell this, but I can tell you there's a really, really strong smell coming from this unit. And I believe half of it is like, geez, I don't know if you can see this, but this is some fungus kind of style that attacked all the wires, and it's really nasty, to be honest. Yeah, I don't know, it's probably gonna blow up or short circuit everything here. Maybe it's gonna take my fuse. But look at that. This metal plate down here is this tin or zinc or something like that. I don't know if you can see the tiny little hair, but we are having all sorts of, let me play around with the light, then you will see those are called tin whiskers, by the way. And it's just because of the chemical components in this surface treatment that makes it possible to solder on these. And for some reason it just grows out. These thin. They are insanely thin. You can hardly see them. And they are, of course, here you can see, they are, of course, electrically conductive. And when they touch high impedance stuff, you have a short circuit, and you can see it is touching those pins down here. So I need to compressed air and a little paintbrush and stuff like that. And then I'm gonna see if I can remove all the nasty fungus and such, and probably be able to power this up. Got some really nice components here. Yeah, let's see what happens. with a little bit of cleanup here. I may have underestimated the challenge of the potentiometer here. This one is normally easy to figure out. So I release this little nuts and all that kind of stuff. It's lying right here. And then my idea is that I should be able to pull this up, but it's just so stuck, and I'm using all sorts of tools and a new knob on here, and I can kind of turn it a little bit. There's no way, man. And we got a winner. So that was a trick. Put it in here and turn it and pull. And here you go. See? Just with two little fingers. Easy, easy. I bet it's has never been like this good. Nice, nice. I, of course, used my little drilling machine and just moved it in and out while spinning it real fast and adding a little bit of oil. And then just cleaning and cleaning. And, now it is all nice and fine. And there isn't any slip, slap or anything. So that is fixed. And then I can proceed with the next little fixy thing here. I'm still poking a little bit around with these capacitors here. So I desoldered one of the wires and I'm doing a little bit of measurement here. It says, you can actually read this. See, it says 1 microfarad. But really, it measures almost 20. I got about 20 mega ohms of leak in the first one. But that big one here is about 220 microfarads and a leakage of 4.7 mega ohms. So I think I want to unscrew them, or at least the first one, so I can read what is the official value written on that one. Otherwise I can't restore this. I will just try and solder another capacitor that's hanging here in the air just to see if I can get the capacitance measurement up and running here, because now I fixed the potentiometer, so that is like brand new and nice. So why not see if I can get all this up and running in case the amplifier and all that is up and running. See, I cleaned all the tin whiskers away and I put in a new fuse. So I think I am good to go. Oh yeah, you want to see the old fuse? Oh, that is so nasty. And I think it's some sort of the tin alloy or the way that they make this look like chrome or something. It is always the fuses on really, really old equipment. They end looking like that. This is a bad capacitor. See, it's going all the way out of its container. So there's something that is wrong with that one. So here's our 1 microfarad. So this is the official value, but I measured 20. How can I measure 20 times as much? And here's the fun thing. The other one is rated 10 micro, and I measured 220. I think I'll go and get another measurement method, because this can't be right. So now I'm using another way of measurement, and this one I can adjust the frequency, and I'm measuring the series resistor and the capacitance, right? So at 50 hertz, and I think this instrument uses 50 hertz, right? The mains frequency for its measurements. But if I change the frequency, I can get almost whatever I want. So at 100 kilohertz, I get the correct. Just to show you, it's not me who is crazy. See, here's a normal film capacitor. This is also rated 1 microfarad. So let's try and do exactly the same experiment with a more recent type. Let's go up in the frequency. See what happens here is that I get more or less the same capacitance. See, of course I will get much less internal resistance. So what I'm saying is this resistor or this capacitor they're using is just really bad. So this is of course one of those more modern measurement systems, and it is of course connected to my computer. So all I have to do is run a little Java script, And then I have all the curves, the two measured signals, as you see here on the screen. I have those as curves on the screen, and I can export this as a CSV file, and I can do this with both of the capacitors, and I can then have it into a spreadsheet and do all the curves and compare and all the fantastic things. And this is shown here, so you can see the difference between the two capacitors. So that's quite interesting. And this tells me that those old capacitors, they're completely useless for any kind of measurement equipment. You shouldn't have values that changes so much versus frequencies. So I will have to put in some new ones and then see if I can get my unit up and running. So now I'm going to assemble everything, and let's try and power this up in a few moments. But first I really want to show you, this is the socket for the EF12 pentode. See, I polished it a little bit so it's nice and shiny. This is a beautiful pentode, and I want to show you this little shield metal. So this is the shield metal that goes all the way through the socket and sticks out the bottom part, and you can solder on it, and everything you have that goes to ground via resistors and stuff goes to this shielding plate. So this is built into the socket, and it goes a little bit up here into the tube itself. So really, really nice. If we look at the tube data sheets, it says all about the different voltages and currents and gain at different currents and voltages and all that. And you can easily see this is a high gain tube. So that is probably why they use this special pentode here. That is to get quite a lot of gain. So stick it, and this clicks in and it holds in. And this is a really, really nice socket compared to these really, really annoying and absolutely bad sockets. Normally the tubes, they just fall out of these sockets if you're not real smart. Let me see, how's this going? Is it like that? I'm not the smartest person in the world. I'm not able to figure this out. I mean, we got that many combinations. How is that possible not to just plug this in, man? It gotta be like this. And this one goes in quite good. So I think this is a good socket. But I actually found loose tubes inside instruments using these type of sockets. And this is the same, just the side connector sockets here. I mean, oh yeah, when you polish old tubes like this, please don't polish them where the text is. It's okay, it's sturdy where the text is. You just want to leave the original text. All the other places where the glass is just glass, yes, you can polish and make it nice and shiny, especially here at the front. Oh, I really hope we're gonna get at least a little bit of picture on this. That would be fantastic. I think we're ready to power it up. I want to dim the light here so we can see if there's any filament. The only place where I should be able to see filament, that is in the magiceye, but it's also really, really difficult to see it in some of these magiceyes. And I will just try and crank up my vario. I think it is turned. Yes, so down here is turned on. So this is 50 volts and it's using about 2 watts. So this tells me I can easily just crank up. Look at that. 100 volt and it's using 4 watts, and I'm looking for filaments or anything. 150, and that is 6. let's just continue all the way. This is only 10 watts. 15 watts at 100 and nearly 200. I still don't see any green. So I will stop at 220 because that is the nominal voltage for the good old times. But we don't see any light in the EM tube. So I will have to investigate if I got anode voltage, if I got filament. I think I don't see any filament there, right? I think I figured out why there's no life so far, and that's because we don't have any anode supply. So now, why isn't there any anode supply? I removed the two capacitors here. Look at those oldies. So this is 8 microfarads, 350 volts, right? And here's the funny circuit. So this is the backside of the beautiful AB2 double diode. So the way that this works, this is anode and the anode. This goes, of course, to the transformer windings, and there's about 10 kilo ohms from these two to chassis, and there's of course a ground, a sensor tap of the windings. So that will be the two sides of the high voltage, and without the tube in, I measure about 250 volts AC on this one and on that one to chassis. So far, so good, right? That will be my filament. That will be my filament. And this is the cathode. So this is my positive voltage output. This one goes to the anode supply here. This is the anode resistor. And that one goes to the anode. That is the two filaments. And yeah, we got about 5.5 volt on the filament. So it is more or less up and running. And I believe there's also a wire that goes all the way to the magiceye. So far, so good, right? And we haven't got any anode supply, only about positive 18 volts. So something is either shorted, probably some of these components here or something like that, or the capacitors here, they're not working. So my idea was, first, let's just try and put in some new capacitors. And the funny thing is, this is a new modern capacitor, 10 microfarad, 400 volts. Look at the size. So I think that I will do that, but I haven't figured out the schematic entirely, because remember the two capacitors, one goes to chassis and of course to the positive, and then the other capacitor is also connected to the positive here, and then the other side of that capacitor is connected to this little pin here. And this one goes, I believe, just to the transformer, probably nothing else. And then a 10K resistor to ground. This one is ground. I've measured there's a chassis on that one, right? So what's the point? I mean, I don't get it really. What is that circuit doing? Maybe there's a wire from this point to something else. I can't really figure that out yet because I can't see anything down there, but at least I need my anode supply, and we'll see where that is going. What do you know? Now we got about 300 volts of anode supply, and look at that. So this is real funny on the video. This goes blinkety blink, and that is of course because this is AC. Well, this is something I don't see in real life here, but it is of course measuring on using AC. So there isn't any diodes or anything like that. So that means it is weak, the readout here of the magiceye. But what you can see is that it is responding, and I put in a 3.3K or something like that. So I should imagine that this is the range, and then it is up here, and down here it should is down here. I don't know. I haven't yet figured out the scale. It's just I don't know. Weird. So that is just all the way down, and in here it's all the way up there. I don't know. What is this percent thingy? You're doing nothing. And there's also something called control. What is that doing? not a lot or nothing. Probably for capacitors, right? So that will be the smallest capacitor. Yeah, but there's definitely life. I tried a lot of different capacitors. Just left one here just for the illustration. I do believe that I need to put it over here where the C is marked. I can't seem to get any kinds of peak, no matter what kind of ranges or what kind of values I play around with, no matter what I dial, no matter how much gain I got. I mean, there's just no response whatsoever. So there's definitely something here that is not working in the capacitance measurement part of this unit. But I can't really invest a lot more time in this unit right now. I think I managed what I came for, to get life in my fantastic magiceye, and I'm super happy about that. The funny unit here is kind of explained more or less. I think I know how it works, but not really super duper good. I got a little bit of indication here. This one says the two bridge resistors, where you can probably play with external bridge resistors. I expect it will disable the internal bridge resistors in this mode. And percentage is probably where this knob here is having an effect somehow. But anyway, this is what I wanted to show you guys. So thank you very much for watching. Please like and subscribe, tell your friends and all that kind of stuff. And come back real soon again. Bye bye.
Welcome to a new test and teardown video.
Thank you.